We're in the final hours of the STS-34 launch countdown at this time. Everything is proceeding smoothly here in the firing room, at the Launch Control Center, and at Launch Pad 39B. A full 5-day mission begins with the primary objective of deploying the Galileo spacecraft from the payload bay so it can begin its 6-year journey to the planet Jupiter. Several scientific experiments will be conducted, and orbiter detailed test objectives will also be performed during the mission. And we have the STS-34 flight crew with a pumpkin decorated in an astronaut suit. We've got Commander Don Williams. This is going to be his second flight today. We've got Mission Specialist Franklin Chang Diaz making his second flight as well. Mission Specialist Shannon Lucid, this is her second flight. And Mission Specialist Ellen Baker making her first flight today. Pilot Mike McCulley also making his first flight today. Flight crew will be departing for the launch pad in about an hour and 10 minutes or so after they get their weather briefing and don their flight suits. Weather forecast for this morning remains the same, with a 60% chance of not violating our weather criteria. They're called crew altitude protection systems, and they have consist of a helmet. These are pressurized garments, and they do wear gloves and boots. There's pilot Michael McCulley. This Mission Specialist Shannon Lucid. Crew does need assistance getting into these suits. They are bulkier than the other suits that were worn previous to the STS-26 mission. This Mission Specialist Franklin Chang Diaz. And we got the flight crew here, led by Commander Don Williams. STS-34 Commander Don Williams now preparing for his entry into Atlantis' crew module. Williams is a captain in the United States Navy. He was born in Lafayette, Indiana. Mission Specialist Shannon Lucid is being prepared to board the orbiter at this time. She was born in Shanghai, China, but considers Bethany, Oklahoma her hometown.
958, 959 are complete, and 960 is not performed. Thank you, sir.
At T-minus 7 minutes 30 seconds, the orbiter access arm will be retracted away from the vehicle.
We get a go from flight before 5. PLS entity. PLS will go for OAA retract. Go ahead, NTD. Okay. configured to hold at 5. Countdown clock will hold at T-5 for your request.
We start a retraction of the orbiter's access arm.
NTD flight 212.
Go ahead, Flight.
Okay, we're going to be go on TAL, but we're going to have to switch sites to Zaragoza. So we hold at T-5. We can give the crew an update.
Copy.
At this time, the three main engines are being gimbaled and positioned for start.
OTC 1081 is complete. Copy.
Liquid oxygen tank now reported at flight pressure.
Warning memory is cleared and no unexpected messages.
Copy, and flight crew, close and lock your visors, initiate O2 flow, and have a good flight.
T-minus 2 minutes. Flight crew's been instructed to close their visors. Less than 2 minutes away now from launch. All systems are go. T-minus 31 seconds.
TLS is go for auto sequence start.
We have a go for auto sequence start. Atlantis' 4 redundant computers have primary control of critical vehicle functions through liftoff.
20.
T-minus 20. T-minus 15. 11, 10, 9. We have a go for main engine start. 6, 5, 4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
Houston now controlling.
Tower clear, well programmed.
Roger, roll, Atlantis.
Roll program initiated, about 110-degree roll maneuver. Guidance confirms a good roll maneuver. 3 engines throttling back now to 65% as Atlantis passes through the area of maximum dynamic pressure. Throttle's now at 65%. APU's looking good. Velocity 2,000 feet per second. Velocity now 1,400 feet per second. Downrange distance 3 nautical miles.
Atlantis, go at throttle up.
Engines now throttle back. Engines now back to 104%. All systems performing well. Standing by for separation of these solid rocket boosters at 2 minutes and 4 seconds. Velocity now 2,700 feet per second, downrange 10 nautical miles. Separation of SRBs confirmed. Velocity now 4,200 feet per second, downrange 33 nautical miles.
Frank, it's an incredible ride.
You looked great. Congratulations to all of you.
Atlantis, Houston.
Houston, Atlantis.
Roger, Shannon, it's been a long time coming, but you have a go for deploy.
Okay, understand. We have a go for deploy, so we're starting out on step 5, the top of page 4-10, and just pressing on.
Roger, we concur with that.
Mike, we're ready to maneuver to Galileo deploy attitude.
That's right.
Okay, let's verify the DAP is speed, auto burns.
All right, and I need to change the ADAP
Change your ADAP to 11. While you're doing that, I'll set up the time display. Okay.
A11 DAP is in.
Okay, that's set. Okay, ADI switches, mine are set.
I'm in LVLH.
Okay, track option, target ID 4, body vector 5, verify that.
Verified.
And 247.7, 0, and 270.
Okay, and ready
Okay,
to
let's
initiate
initiate track, item 19.
Execute.
Okay, good. Verify your flight controller power's off.
Mine's off.
Okay, and now remember when we get in attitude, and this is about looks like about a 7-minute maneuver. And when we get in attitude, we want to remember to go to A11 auto burns, norm low Z, and false on the rotational DAP.
Vehicles released. We got all the verification for that. And IUS is moving up to 58 degrees. So it looks like, so far, it looks like it's going pretty good.
Okay, that's great news, Shannon. Thanks.
Ground telemetry is confirming Shannon Lucid's report of tilt table motion. The tilt table was at 29 degrees. It's now moving up to an elevation of 58 degrees. That's the deploy attitude. And the Sunnyvale flight director has just confirmed the successful deploy of the inertial upper stage and Galileo. Galileo reports positive telemetry of deploy. Also, we see the orbiter performing a minus X translation maneuver to move away from the IUS Galileo stack.
Time, Houston. The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Fly safe.
Roger, Atlantis, we copy. That's great news. Thanks.
Is this the real life? Is this just fantasy? Caught in a landslide, no escape from reality. Open your eyes, look up to the skies and see. I'm just a fool boy, I need no sympathy. 'Cause I'm easy come, easy go, little high, little low. Any way the wind blows doesn't really matter to me. I see a little silhouette of a man. Scaramouche, Scaramouche, will you do the fandango? Thunderbolt and lightning, very, very frightening me. Galileo, Galileo, Galileo Figaro.
Good morning, Atlantis. we thank you, and we're sure glad you recognized it.
On board the shuttle, we carry a first aid kit. Fits into one of these lockers, which is where we store most of the materials and experiments and day-to-day living items that we'll need. And our first aid kits carry pretty much what any doctor's black bag would carry. Only our kits look like this. We carry a stethoscope, of course. And we pack in this kit things you might find in a drugstore: bandages, adhesive tape, Tylenol, aspirin, some of the common medications for colds, sniffles, sneezes, runny noses, things like that. And we also carry a few things just in case there are some more serious medical problems. If I could have my patient, please. Simple. What if Shannon had an earache? Well, we carry an otoscope, and I could look in her ear. It looks okay. If she had a sore throat, I could look down her throat. That looks okay too. And if she felt like she was getting a little feverish or had the flu, I could take her temperature. So you see, we carry some very basic things, like you might expect to find in any first aid kit. There's not always a doctor on board. As a matter of fact, there usually isn't a doctor on board. So we generally train 2 crew members in how to handle basic first aid problems, very basic medical problems, and all crew members are trained in CPR and things that you might expect that anybody would need to know. If something comes up that the crew can't handle, we have a few options. We have a medical checklist. And the checklist will tell you how to take care of things such as a cough, back pain, and also some more space-related problems, motion sickness, problems during EVAs, the bends, things like that. If we can't find the answer in the medical checklist, we have a video link and an audio link to the Mission Control Center where we can talk to a flight surgeon who sits on board there. We've been lucky so far. We don't anticipate having any medical problems in the shuttle that are serious. However, we do have to think about what to do for space station. We'll have larger crews going up for maybe 3 or 6 months at a time. You can't run to the emergency room. You can't give your family doctor a call and have them come by and make a house call. So we're considering expanding our medical capabilities so that we can handle things like minor surgery or even medical stabilization of a patient who's got some more serious problem. In the shuttle, we're not that far from Earth. We can come home fairly quickly if there was a true medical emergency. In the space station, we might not have that option. We'll be back with you later to talk about some of the medical experiments that we're doing on board the shuttle Atlantis. Until then, have a good evening.
Franklin's loading it up. Why don't you say what you're doing here, Franklin?
Put in the pressure plate, hold the film flat, and each exposure frame. Now I'm gonna check the film here, and it slides good. Close the pinch roller over here. Set up the There's Kitty Hawk. John, at 250, a Kitty Hawk might give us something.
Yeah, you got it.
There's ships, weights, and ships.
And you can see the door lid is open, and the instrument is taking in all the information. Now, I'm getting ready to terminate that because we're finished with the solar view attitude. We're getting ready to go and do another Earth view. And to do that, we have this little controller here, and it's a very simple, small handheld controller that issues commands to a set of relays in the canister, and we're just getting ready to end the solar view, which is to take one of the relays, relay 07, from its hot state to a state called latent, and we're just about to do that. Okay, he just did that, and now the door ought to begin to move any time now. So you see how the door slowly closes, just like a clamshell. And it's fully closed now. We obtained these pictures of the retina. This is Ellen's retina with the The fiber optics device that we've been testing is a demonstration of a really good capability that we now have, and it's part of our orbiter crew equipment. I'm sure we can do a lot better, of course, if we provide these pictures in color, and that ought to be the next step, probably. Maybe with the next camcorder that we fly, we can fly this sort of thing with a C-mount and mount the fiber optics on it. But as you can see, we can do real-time diagnostics from space.
Good morning, Atlantis.
TJ, we send you the best from Northern Australia. It's a little dark out our windows, but I expect it's probably about time to get off third shift where you are.
That's affirmed, Don. Your execute package should be on board.
You can hear the whine of the WCS, and Franklin is getting prepared for his international phone call. His hair is full of soap. I don't know how he's going to get it out. Well, our hair is clean now. Time to shave. He looks good. Look at that hair. Gonna put the rest of us to shame, Franklin. Look this way. This is the sound of the treadmill.
Gotta get this on Ben Burt's tape.
Yeah. Hey, Mike. Get this on Ben Burt's tape.
This thing gets pretty noisy if you get it going.
think Franklin smells that.
And this is meal prep, lunchtime in the mid-deck of Atlantis. Everybody trying to grab a bite to eat before somebody else gets it.
After that, it's probably tough when you're competing with a couple of maggots.
Yeah, it's tough. Coming on down here in the lockers set up here for PM, what you can see is the actual computer where all that information is being stored, and the canister, which is this one right here, which contains a very large number of cells which are being processed, and where all the samples are. There is a carousel inside this canister that rotates and positions the cell so that the interferometer can look through the windows of the cells and then derive the data. And inside also the center of the canister, there is a source of infrared light, which is very carefully maintained, and that's why we had at the beginning part of the mission. We had a little bit of problem with the steadiness of that temperature, and we were able, by communicating with Dr. Cook on the ground, you guys working this problem, we were able to recover the functioning of the STIR to a level where we could use it, and it's been working like a champ all this time. And when the sample is molten, it begins to cool it down on a step function, steep trajectory down to another temperature, which looks like is about 125 or so degrees, at which time it holds it there for the remainder of or most of the time, and we're up to the 6-hour mark right now since that sample has been cooking along there. And eventually, at some point, about 19 hours or so, or 18 and a half, it'll stop that steady state, and it will bring it down back to room temperature. And all this time, the infrared instrument is the infrared interferometer that's inside the PM experiment is taking data about what the structure of the crystals in the polymer, which is the kind of thing that we're looking at right now, is polymers. The crystal structure in that polymer, what it looks like, and it gathers all that data and stores it into a computer, which is right here on board. It's not this computer that you're looking at, but it's another computer, which is in one of the canisters down in the lockers. And all that data then is then collected, and when we come back to Earth, why the people at 3M, Dr. Cook and all his colleagues will analyze it and hopefully discover or perhaps tell us something new about how polymers behave in zero-G. I don't know if you can see the lightning. It was over the last two passes over the African continent, the southern portion of the continent. And of course, it was done with the black and white cameras for low light sensitivity.
This is live downlink coming to you now. If you can see that, perhaps you can see the same sort of thing we're looking at.
We see it.
That looks great.
focus on the filament wire where the crystals grow is excellent. It appears to be very sharply in focus. However, we haven't seen any crystals yet, and I don't know whether that's to be expected or not, but we're kind of waiting to see how that comes out.
Okay, and Houston, now we switch to live crystal growth.
Roger, understand.
It says, slowly inject 10 cc's of water. Will I be there?
This morning when I got up, I took scope decks, and then at 30 minutes, 1 hour, 2 hours, 4 hours, 6 hours, 8 hours, and now 10 hours after I took it, I've been collecting my saliva so that when we get back to Houston, the lab can analyze it and see how much of the drug I've absorbed. There's been a feeling that perhaps drug absorption and metabolism is different in zero-G, and of course this would be something that we would need to know if we do have people living up here for long periods of time, because some folks will need some medication, and if the dosages need to be altered because of the weightless environment, then we would like to know this. So that's what I'm doing right now. To collect the saliva, I have a little cotton ball. And I just put it in my mouth and chew on it for a little while and soak it up. And like I said, then we'll send it back when we get home and see what the lab has to say.
The rest of us down here appreciate the medical work that y'all are doing, Alan. We hope that it makes our flights better.
Okay, flight day 4, transcranial blood flow. Shannon and Don.
It's beginning to come back up again.
This is Ellen, taking blood pressure. Boy, look at that concentration.
Probably one of the better fall days you've ever seen at Northrop Strip. You should be out there today, Bakes, instead of sitting inside Building 30.
Yeah, I could go for that.
But what else would you rather be doing on Sunday afternoon?
It's a beautiful day here. It's warmed up a bit. I guess it's about 78 or 80 degrees out.
Gee, I hope we don't miss fall.
That's right. They saw a ready light on PM. Could you check that for us? He expected something different.
Ellen said to look at the camera, but what we're talking about is tags. You can see this last piece of paper. If you look carefully, I'm not sure how good it comes down, Jim, but it's bowing. It's got a lot around us, and here comes the other one on top of it to the top of the tray. And this is the sort of thing I was talking about earlier. Very little room left in here. It tends to pack it, but there's a lot of curvature that takes place in the thing. But anyway, we're really happy with it. The quality again has been excellent, particularly on the reproductions of the GO satellite information, the things that you all have put on top of orbital information and times. The quality of that print has been good, and the quality of all the messages.
Right now we're working on the growth hormone concentration distribution and plants experiment. We have 4 containers that have corn seedlings in them, and we are going to freeze 2 of those 4 containers, and post-flight Dr. Bandersky and his team will be examining the corn seedling for growth hormone. You know, plants tend to grow upwards in the 1G environment, and we're not exactly sure how the growth hormone will be distributed in this weightless environment. So we have this little nitrogen freezer on board here, and Shannon just put one of the canisters into the freezer.
Atlantis Houston, the lake bed is go, and your go for deorbit burn.
Go for the burn. Thank you, sir.
Roger that.
Atlantis should cross the California coast at about Mach 4 at an altitude of 105,000 feet, approximately over Malibu, California. Television cameras at Edwards have picked up a visual on Atlantis, now at Mach 2, 77,000 feet altitude, 48 miles away. Velocity now Mach 1.6, altitude 69,000 feet, 38 miles out. Atlantis now over Rosamond Dry Lake bed.
Atlantis Houston, your nav looks good. You can disregard the nav edit message and hold on air data to nav.
Roger.
Velocity now 900 feet per second, altitude 41,000 feet.
Atlantis Houston, take air data to nav.
Air data to nav.
Atlantis Houston, you're looking great. Turning on the hack. Surface is clear. Altimeter is 3019.
3019, okay.
Atlantis now right on the imaginary line around the heading alignment circle. Velocity is 500 feet per second, 5,800 feet altitude. Range 3 miles. Landing gear down and lock. Main gear touchdown. And nose gear touchdown. And Atlantis rolls out at the conclusion of mission STS 34, correction. Unofficial main gear touchdown time was at 9:33 a.m. Pacific Daylight Time.
Houston, we're stopped.
Roger, Atlantis. Congratulations on an outstanding mission. You've extended the shuttle's reach to the outer planets. Bravo Zulu.
Thank you, sir. It's nice to be home.
Roger that. Mike, we'd like APU-1 shut down, please.
You can work.
And stand by for further
without you guys, so super support.
Roger, thank you, sir.
STS-34 crew led by Commander Don Williams coming down the stairs at Dryden. There to greet them is Admiral Richard Truly, Administrator of NASA, Dr. Bill Lenore, the Associate Administrator for Spaceflight, J.R. Thompson, the Deputy Administrator, and Michael Coates, astronaut, as well as Don Putty, Director of Flight Crew Operations at Johnson Space Center.